Today's video is about natural logarithms. So write that title down. The learning objective is I will learn what natural logs are so that I can use them to solve equations involving e. So write that down as well and pause the video so that you can do that and press play when you're ready to keep watching. Alright, I want you to start off by sketching the function y equals e to the power of x. So just pause the video and do that now, please. Hopefully you're very clear about this because you've done it a lot of times over the last week or so. It's an exponential function, which means it looks like this, and it goes through this point 0, 1, because when x is 0, y is 1. Today, we're going to look at logs with the base of e. So if we take the log with base e of x, this is called a natural logarithm, and it's actually shorthanded to ln x, or ln x. So ln x is actually on your calculator. It's next to the log button that you've been using so far, and it just means log with base of e of x. There's a few interesting things about this function here. First of all, it is a reflection of y equals e to the x, and it looks like this. With the asymptote where x equals 0, so the y-axis. Asymptote y-axis, x equals 0. And the reflection itself is through the line y equals x. So the natural logarithm, or ln x, is a reflection of y equals e to the power of x through the line y equals x, as you can see on my graph here. So that's the first thing that's interesting about it. It's a reflection in the line y equals x. This is only defined for positive values of x, because e to the power of anything is always going to be a positive number, because e itself is a positive number, which means it's always greater than 0. So therefore x must always be greater than 0, which is why the asymptote is the y-axis. If you need to rewind that so that you can get your head around it, please do that now. Now the graph is actually not what we're going to be focusing on today. What we're going to be focusing on is the fact that log of base e of x, in other words ln of x, is the inverse operation to e to the power of x. And so we can use it to solve equations involving e to the power of x. So we're going to start off by looking at, not that example, at this example over here. This is actually example 17 from the textbook, but don't worry about that for now. So if you're asked to solve e to the power of x equals 5, what we can do is take a log of both sides, but we're going to make the base of the log e. In other words, we're going to take ln of both sides, and then, as you well know from all the work that you did yesterday, the power then comes down. And crucially, remember, this is just log base e. And we know that that is the same as 1. So the left-hand side simplifies to x equals ln 5. Now actually, you're probably thinking to yourself, you already knew that, because if we rewrite this using logs, what we would do is we would say log of base e of 5 equals x, which is the same as ln of 5 equals x. And you're completely correct. These two things are obviously the same. But the key message is, if you have an equation with a base of e, like this, and x is the power we can take natural logs of both sides, and the natural log will cancel the e, leaving just the power. And the reason for that is because the natural log is the inverse of the exponential with base e. So natural logs and e cancel each other out. And that is the key thing. If you're going to write anything in purple pen, it is that the natural log is the inverse operation of the e, and so therefore these two things cancel each other out. So my working, if I were going to do a different question, solve e to the power of x equal to 10, I would take a natural log on both sides, and I would know that these things cancel out, leaving just x equals ln 10. So it's not very difficult to do this. You just take a natural log of both sides, and then it gives you the solution. So make sure you made a purple pen note of that, and then we'll look at a question involving the other way round. So the other way round is, if you're given a question, solve ln of x equal to 3. Now, just like ln cancelled out e, if we raise e to the power of both sides, so we write e to the power of ln x equals e to the 3. So do it to one side, do it to the other. Then the e and the ln cancel each other out, and we're left with x equals e to the power of 3. Hopefully, you can spot why that works. Ln of x is the same as log with base e of x equal to 3. And if we have this situation, what it just means is the base is e, the power is 3, and it gives x. You can see that is the same as what we have here. But the quick way of doing all this is we just raise e to the power of both sides, which basically means write e as the base on both sides, and the e and the ln cancel each other out, and then we can solve the equation. So let's just quickly do another example of that. This time, let's say ln of x equals 8. I want you to pause the video and have a go at raising e to the power of both sides so that you can solve to find x. So pause the video and have a go at that, and press play when you're ready for me to go through it. So, because it's ln x this time, we're writing e to the power of both sides. These cancel, and we're left with x equals e to the 8. The key message again is that the natural logarithm, ln, is the inverse operation to e to the power, where the base is e. So those two things cancel each other out when you're solving equations. Let's do one more. Let's say actually, let's pause it there. We're going to move on to the next example, and this time we're actually going to do example 18 as it appears in the textbook. So we now have enough information to be able to solve each of these questions. So I want you to pause the video and have a go at doing this on your own first, using what we've just talked about in the first part of this video. If you need to rewind to get your head around what I've just said, then please do. Otherwise, just have a go. Press play when you're ready for me to go through it. All right, so A, I can see I've got e to the power of something equals 7. So I'm going to take a natural log of both sides. And as I said before, the ln and the e cancel, and we're left with 2x plus 3 equal to ln 7. And now we solve the equation in the usual way. We take away 3 from both sides, and we divide both sides by 2. You can either write it like this, ln 7 minus 3 over 2, or you can write half ln 7 minus 3 over 2, or some variation of that. They're all acceptable. Now, when it says leave your answers in exact form, that means we're going to leave it with the ln. It's a bit like leaving your answers in terms of pi. You're not going to do the calculation because that would involve rounding, and therefore it wouldn't be an exact answer. So if it says leave your answer in exact form, you're going to leave it with the ln or with the e, because as you'll see in the next question, we're going to be leaving it with e. So we'll look at B now. I'm going to write out the question again. So the first thing I want to do before I try and raise e to the power of both sides to cancel this ln, I'm going to get x. I'm going to try and get ln on its own first. So I've got to get rid of the plus 1. I've got to get rid of the times 2. So getting rid of the plus 1 first of all, taking away 1 from both sides, dividing both sides by 2. And now I've got a fairly simple equation. I'm going to raise e to the power of both sides. Not doing. And therefore the e and the ln cancel, and I'm left with x equals e squared. That is an exact form, because if I were to actually type it into my calculator, I'd have to round it. So just like we left it with ln over here, we're leaving it with e in part B. So pause the video and make any notes that you need to, and then we'll move on to part C. So this one, e to the power of 2x plus 5 e to the x equals 14. I'm immediately looking at this and I'm thinking, this power is double this power. And when I have that sort of situation, that means it's a quadratic equation, and I need to somehow solve it like a normal quadratic equation, meaning I may need to factorize if I can, or I'm going to use the quadratic formula to solve. So first of all, I've got to get it in the form ax squared plus bx plus c. So I'm going to move the 14 onto the side. And then I've got this situation again. So what two things time together to make negative 14 but add up to make 5? That's positive 7 and negative 2. And what's going in the box is going to be the smaller of the two powers. It's going to be this e to the power of x. So writing out nicely, I've got e to the power of x plus 7, e to the power of x minus 2 equals 0. And so now we go about solving this in the same way as we have done for all the other questions like it. E to the power of x plus 7 equals 0, which means e to the power of x equals negative 7, and e to the power of x equals 2. Now, because e is a positive number to the power of anything cannot give us a negative. So this has no solutions, this one here. So we can ignore that for the time being. And now we're left with e to the power of x equals 2. So I'm going to take ln both sides, so log of base 2 on both sides. It's going to cancel this, and I'm left with x equal to ln 2. And because I'm leaving it in exact form, I'm going to leave the ln there, and that's finished. So I'm not going to go into any more detail for the time being about the natural logarithm, so log with base of e, because it might end up confusing you. The only thing you really need to take from this video is that to cancel out the e, when you're left with a situation like in part A or part C, you take a natural log on both sides. And to cancel out a natural log, you raise e to the power of both sides, like I did over here. Everything else is just using your knowledge from previous lessons, from previous topics that we've done, like solving quadratics. And so you should be all set to complete exercise 14G. There are some slightly harder questions in exercise 14G. So if you do need help, please, as always, just email and we can help you.